Hi, I'm Aryan Karani from Kid with a Camera. So I wanted to make a full APCS course, but I realized there's really no point because the AP test is coming up, and what people really need right now is some kind of review on the topics that people are mostly confused about. So most of the videos I'll be doing next are requested videos from my friends at school and things like that. So without further ado, let's get started. Today we'll be talking about objects. Before we start, I just want to say I'm open to suggestions for all of my videos. So if you have something I said completely wrong about programming, or just a tip to improve my videos, put it down in the comments. And yeah, let's get started. So Java is mainly an object-oriented language, and we have a lot of object-oriented languages in the programming world. We have Java, Python, and C++, and some languages are built for object-oriented programming and optimized for it, just like what APCS teaches, which is Java. Basically, what object-oriented programming means is you have a lot of files, and each file represents an object with one main file that runs all the code. And it's better than just having one long file running all of your code. You can split up into multiple files. It's kind of like what you learn in APCS procedural decomposition, but you're making objects to do it instead of making a bunch of methods. So to teach this, a really nice example is say you're coding something for a flight, an airport, for example. There are a lot of components to this. You need to keep track of the flights and what airlines are in the airport and the different airports and the different types of planes and the passengers in the flights. You have to keep track of all of this, and putting just a bunch of array lists, after there's a passengers, there's a flights, it just gets really messy and sometimes doesn't even work. So the way we solved this was object-oriented programming, which is where you have a separate file for, say, a flight, a separate file for the airport, a separate file for what a passenger is. You're basically creating your own objects in Java. There are a lot of components to making a code for an airline or an airport. You have to keep track of the flights and what passengers are on the flights, and so much more. So that's what object-oriented programming helps with. So we've been using objects in Java without even knowing it. We have the string object, we have the scanner object, and you can call methods on these objects: scanner dot next line, or next int, or next double. These are all methods that you can call on the scanner object. And then you have the string, which you can do dot to uppercase, dot to lowercase on a string. Essentially, object-oriented programming is creating your own object so that you can make your own custom representations of what you want in your program, so that you don't have to rely on someone else's interpretation of what you want. You can create your own, and it just makes Java so much more powerful. Now back to the example of flights. You could probably, I don't know, I have no idea how to do it, but you could probably make a bunch of array lists, like array lists for passengers, for flights. But what it would do is would make the program very complicated for trying to link those flights to the passengers, and the passengers to the airlines, and the airlines to the flights, and flights to the airlines. See, object-oriented programming can solve all those problems for us, which is why it's so much more powerful than the procedural decomposition with one file and a bunch of methods we've been using till now. So one object we can have is a flight, which can store the data for the passengers, what airline it belongs to, the name of the flight, the departure time and the arrival time. You can even make different objects for representing departure and arrival depending on what data you want in those. And an example, for a flight object, you can have an array list of passengers. So you can use objects within objects to make Java even more powerful. And then you can have an airline flight, which can have a list of flights, an array list of flights. So the custom object and a new custom object, which is why this becomes so much more powerful, because you can have objects within objects and have this kind of link between them. And you can create IDs, custom IDs for these objects to make recognizing them in your program even easier. So then you can have the airport object. You can say this airport supports this many airlines, and within those airlines will have data on flights, passenger, which the flights will have data on passengers. You can see how this just goes down a tree, but it's way easier than going down a tree of array list. You can just go down the tree of objects. So now the part you've all been waiting for, let's look at some code. So I'm going to be using the airplane example because I think it's good to look at a little complicated example when you're doing object-oriented programming. So we're going to have three files, test.java, TestFlight.java, which will be kind of our executable file. I like to call it test something. That's probably because that's what I learned in my APCS class. And then we have a Flight.java and an Airport.java. And also I have to leave for a flight in like not too long, like an hour, and that's not great. Anyways, I'll see you when we're writing code. Hey guys, so now is the part you've all been waiting for, which is getting into the code of object-oriented programming. This might look a little complicated at the moment, but I'll break it down and show you what object-oriented programming looks like in practice. What you see up here is just a simple import statement, which will be explained. Oh, and I forgot to mention, this is the Flight.java file, and we also have an Airport.java file and a TestFlight.java file. And believe it or not, this is the second time I'm recording this, because the first time I typed out these files again and I realized that took too long. So I'm just going to be explaining them, and you can find all these files on my public GitHub, which I'll link down in the description. Here you see a simple import statement, which will be explained later in the code. This is a little description of the program. This is a program for the objects video I'm making. So quick description, it'll contain things like departure time, arrival time, the departure location, arrival location, airline name, passenger capacity, and a unique flight ID, which will be very important later on. So of course, our code starts with, what it always usually starts with, which is public class flight. So now there's like series of steps, like it's kind of like a sandwich, I guess, making an object I like to follow. And the first one is instance variables, which is what is your object storing and why are you making this. If you're making a score object, you want to store two integers, one for player 1 score, player 2 score. So what is this object storing? What are you packing into this object to make what's already in Java more useful? The second is the constructors, which is the method kind of thing you call to get the object initialized, which will be something like for, let's say, Flight.java, it will be flight, name of the flight, say flight test equals new flight, and then these are the parameters you'll be putting in that. Let me just close this real quick. These are the parameters you'll be putting so that you can assign everything and then do whatever you need to. Third thing is accessor methods, which is basically a bunch of methods that allow you to get copies of whatever you have stored in this object, so the user can take that and do whatever the user needs to with it. These accessor methods are really only used when you have instance variable that is private, because what private basically means is that only this class can actually access them and modify them directly. Otherwise, you need these accessor methods so that you can get those values. The last thing is the modifier methods, which is basically used to modify the object and its instance variables. Yeah, the user can modify things and add things and subtract things, and so that's basically what it does. Finally, I like to add a toString method, which is basically how is this object being represented as a string. So let's go all the way back up and look at our instance variables, which is the first thing I like to write when I'm making an object. So the first thing I have is this local date time. What is the local date time? The great thing about this Visual Studio Code, which I'm using right now, is that it'll give you a description. So it's a date time without a time zone in the ISO 8601 calendar system. I have no idea what that means, but basically what this is storing for this tutorial is the date and the time. The variable names are basically describing what date and time. What does the date and time mean? So it's the departure date time and the arrival date time, which you would need for a flight. You'll probably want to know when that is. The second is toStrings, which is departing from and flying to. And what these two strings are doing is it's a string representing where you're departing from. Say you're departing from Los Angeles and you're flying to Seattle. So departing from would contain the string Los Angeles and flying to would contain the string Seattle. Next is the name of the airline, also as a string. Delta, United, there's a lot of them. That's what it's storing. Next is the passenger count, which is an integer because you want to know how many passengers are on the flight. The passenger capacity, which is how many passengers can this flight take. Probably useful when you're dealing with booking flights. You want to make sure you don't go over the passenger capacity and overbook the flight. Third is the flight ID, which is a unique ID for this flight, and implementing that is a little advanced and complicated, but it's pretty easy. And the private static int next flight ID. So this is also an integer which is going to store the flight ID for the next flight object, which is a little confusing right now, but you'll see how that works later on. Just notice that it has this static keyword, and what that static keyword means is that for each instance of a flight, that keyword or that variable will have the same value for all the instances of flight. So every time you change this value, you're changing that value for every flight object that you construct. So next, I like to make the constructors. This is the reason you take the instance variables first, because a lot of the time you have to use the constructor to assign these instance variables to something. For example, the local date time, departure and arrival, departing from, flying to, airline, and passenger capacity. So how you make this constructor is you say public, the name of the object, in parentheses you put all the parameters you need to that the user passes in when he's creating the object, and then you do stuff inside. This is interesting. So we have this keyword, and what that's doing is it's referencing itself. So it's like this flight dot departure, which is the departure up here. And why we need to do this? Because we're passing in a variable with the same name through the constructor. So if we just said departure equals departure, it's like, which departure do I use? The departure that's up in the parameters, or the departure that's in the instance variables, which is what the this does. The this keyword defaults to the instance variables, and since we're assigning to the instance variables, we need to do this dot departure equals departure. And this is a general pattern you'll see. A way to avoid using the this keyword is to name these the departure, the arrival in the parameters different names, but usually this is easier and saves you the time of creating new names. That's basically what your constructor does. And you can see why doing the instance variables first is very helpful. Now, how do I get these instance variables? Like, what do you know what to put there? And this is something you should be planning before you make the object. Basically, you should know almost immediately what instance variables you want. It's just a matter of planning and knowing what you're making. So how I came up with this, I thought about, I have a lot of experience with flying, on airplanes. What do I usually see on that board that has all the information? I see the departure time, I see the estimated arrival time, I see where am I departing from, where am I going, so departing from, flying to. Usually I see the airline, so a string airline. Now what we don't usually see is a passenger count, capacity. This isn't just for the user to see, this is also for United assistant. When you get into the airport, when you're checking in, you should have this data with you, so that's why we're storing that data. The flight ID is also something we see. These are all things you have to have experience with, or you have to research so that you know what exactly that object needs. In the constructor, I call this setNextFlight ID. We'll get to that later, but basically what it's doing is it's setting the next flight ID, and directly above that you can see this dot flight ID equals next flight ID, and you can see that we haven't passed in a flight ID. There's a reason for that, because I want the flight ID to be generated by the object itself to the next flight ID value, and these two lines of code will be obvious later on. Another thing you notice that I forgot to mention is that I pre-initialize next flight ID, because the first time you make this object, it's going to be calling this line, and if I did not initialize this, it would call an error like, what do I assign it to? Next flight ID is null. So that's why I pre-initialize it. The accessor methods are very simple. You just have the Java convention is just to use get and then the name of the variable you're getting. So I have get departure, which I actually made a typo. Don't worry about that. So that's supposed to be get departure, where we're returning the departure. It's very self-explanatory. All these variable names and method names that you're making, make sure it has a purpose, because it's easier for other programmers if you're collaborating to understand what it is, and it's easier for you to understand what it is when you're making the client program, the main program that you're running using these objects. So I have get arrival, a get departing city, just because it's a little more descriptive than get departing from, sounds more natural. Get passenger capacity, get passenger count. Why did I use public here? Because all programs should be able to access this method Although if you put private, you wouldn't be able to use that method outside of Flight.java. The second thing I put here is the return value, which is local date time, because departure is a local date time. You can see when I'm returning a string, I put string, you know, so on. Method name, curly braces, and return whatever you're returning. So that's very simple to get methods, or the accessor methods. Third thing, modifier methods. So these are probably the most complicated part of your program, where you're deciding, okay, if I was making a program and the user or anybody needed to modify something, what would I need to program in so that they can actually modify it the way they want to? And you have to think about what happens to a flight. When you're reserving a flight, you're adding a passenger, you're not always, but you're taking out passengers. The flight gets delayed, sometimes do all kinds of other things. I made it very simple, but the first thing I put here is public void delay flight, where the user passes in the parameters days and hours, and it doesn't return anything because I don't need to. So what delay flight basically does is it adds days and hours to the departure. These are methods found in the local datetime class. I'm not going to go over that, but that's what it does, plus days plus hours to the departure and the arrival based on whatever the user wants to delay the flight by. That's all it's doing. It's very simple, delay flight. Next, increment passengers. You're adding the passengers, passenger count plus equals passengers to add, again not returning anything, and the user passes in how many passengers to add new passenger. What that's doing is it's just an easier way of incrementing the passengers by 1. How I'm doing this is the user's not passing in the integer 1, but it is just incrementing the passengers by 1. And even if I did want to do that, I could just do this increment passengers, and that would probably work. Basically, it's calling this increment passengers up here, just adding the parameter 1. It's just a simpler way. It might make the programmer's experience easier, maybe not, but you know, it's a good thing to do. Just have a default method for everything. I could actually have overloaded this method just calling increment passengers, but that's my bad. So next, switch airline. Basically, the user passes in a string airline, this.airline equals airline. Again, that this keyword, because I'm using the same variable name in the parameters. This.airline equals airline. Very simple. Set next flight ID. So if you recall, that was called all the way up here in the constructor, and what this is doing is it's incrementing that next flight ID so that the next flight that is created has a different flight ID, or just, you know, one more than the last one. And because this is a static variable, in the method header you have to use the word static before the return value after public. That's just because you're editing a static variable. And when you call this method, it actually calls that methods on all the flight objects, and so the next flight ID is, well, in a way it's not calling the method on all the objects, but it's changing the variable for the class. So basically what that means, if you have next flight ID 0, and then you call this method next flight ID, for everything becomes 1. So that the next time you make a new flight, the flight ID will be 1. And when you make that flight, the flight ID will increment to 2, and so on. So basically this is a way to ensure we have a unique flight ID for every flight. Finally, the toString method. And the toString method, it does have a default value. You want the toString method when you're printing out something for debugging or some other reason, you want it to be a descriptive toString, right? You want it to have some kind of value in printing that out. So basically what I did here is I have this gigantic string, but basically what this does is this format: flight dash United, which is the airline, plus the flight ID, a colon, departing from string on. This is a way I'm printing out the date at the time, and then arriving at the string of for flying to that arrival local date time and the time. Just remember, this isn't a tutorial on how to code a flight and airport program. This is a tutorial on how object-oriented programming works. That's your basic sandwich, of objects-oriented programming. The toString method, and then above that is modifier, accessor, constructor, instance variable. And now let's take a look at Airport.java. I'm going to explain this a little faster, except for the more complicated methods. What Airport.java is showing is that how these objects can interact with each other. So again, we have our import. I'm importing array lists because I'm using that in this program. I'm going to be assuming you know what that is. Program for the objects video contains an array list of flights, name of airport, and I added a lot more. You can see total flight capacity, maybe not a lot more. I also added a new delay flights. And one thing you should know is when you're programming, you sometimes get this new idea. And this programming has to be very dynamic so they can add that new idea easily. How do you think Apple makes its new iOS updates or Google makes its new Android updates? They have to make their OSs able to insert new ideas very easily. So you can see a very similar pattern here, public class airport. Then we have our instance variables, which is an array list of type flight. You're interacting with that flight object. You're making an array list of flights called flights. An array list of object flight called delayed flights, because maybe you want to print out all the delayed flights or you want to know what flights are delayed. Just have those, a separate array list. And there's a lot of ways you can implement this. You could even implement it in the flight object itself, having a boolean in the instance variables, which means delayed, in the flights array, loop through it and find any flights that have that boolean to true and print that out. Or this is another way to do it, whatever's easier for you. In total flight capacity, which is an integer, which is the number of flights an airport can hold at once, and then the name of the airport, which is obviously very important. Next we have the constructors. It's the same kind of thing, public airport array list flights, because if the user should pass in what flights are in this airport when they're initializing it. Total flight capacity is also user passed in, and the name is passed in by the user. So this dot flights equals flights, again same thing because of the matching variable names up here. This dot delayed flights equals new array list. It's just an empty array list right now because no flights are delayed at the moment. This dot total flight capacity is the total flight capacity. This dot name equals name, etc. So now I've also created second constructor, and you can create multiple constructors in an object. The user might want to initialize things to a default, and you should have that default ready. So this is just if the user didn't pass in any flights. What if the user didn't have any flights that I want to pass in by default? So I created a public airport, string name, int total flight capacity. They're only passing in these two parameters, but over here. Again, you see this keyword, but it's not doing what it did over here. When you have this and then parentheses, it's basically calling a different constructor in the method. And here I'm calling this constructor, where I'm, instead of passing in this array list of flights, I'm just passing in an empty new array list. This is just a concise way of doing this up here. I could have, taken all of this, Control C, Control V, and this dot flights equals new array list. But it looks a little messy, and I think it's just a lot more concise to do it this way. So that's why I did it. But just know you can create multiple constructors. Next, accessor methods. This is also very similar to the other one. So these are all your accessor methods. They're very orthodox. Array list flight get flights, array list flight get delayed flights. Don't worry about what's over here. Just worry about this. Public string get name, get total flight capacity, total flight capacity. So that's very simple, very similar to the Flight.java. Modifier methods. Add flight, where you're passing in a flight object. Flights.add flight, very simple. Dot add is an array list method, where you just add an object to it. Delay flight, this is very complicated and I'm going to explain it. What this does is you delay a flight from the airport side of things. So you have a flight, which is called, you pass in a flight object, you pass in the days and the hours you want to delay it. And this sounds very similar to the delay flight from the Flight.java, but it's also very different, and let me explain why. The first thing we do is actually call that delay flight method on the flight object itself, so that the time and everything the date is updated right there. Boolean delayed equals false, and you'll see why we need that later. But for flight, temp flight, just as a random variable name, what we're doing is a for each loop here through delayed flights. Remember that flight ID I showed you? So that's very helpful in matching two flights together, because you can't exactly say flight object equals another object. It's a little confusing to do that, but the flight ID makes it very simple. You're just comparing to integers. And what this is checking is the flight you pass in already delayed? And if it is delayed, then your job is done. You added hours, you added days, you're done. But if it's not delayed, you're gonna remove that flight from the flights array and add it to delayed flights. So you're just switching it so that now that flight is classified as delayed. This is a different delay flight, and it's similar to using two constructors. I'm overloading the delay flight method, and I'm for a different use case. So instead of passing in the flight object, I'm passing in this flight ID. And this is another example of that overloading. So again, another for each loop, do the flights array list, the flight IDs match the flight ID that the user passed in and the flight ID of the flight that you're currently iterating over. Delay the flight using this method, using that flight object, flight days, hours, and then just return. You don't need to do anything else. If you don't find that flight in the flights object, it's probably already delayed. In that case, you can just delay the flight normally and return, because you don't need to switch anything because it's already in that delayed flights array. Finally, this delete flight, which is basically a little complicated, but basically what it's doing is, first, can I remove the flight from the flights array, because it might be a delayed flight, you never know, this flight that you're deleting. So if not flights.remove flight, because again, this is very helpful documentation, the list contains the element that you specified, it'll return true. So basically, if it returns false, which means it couldn't remove it and it didn't find that flight in the flights array, then remove it from delayed flights, because that's the only other place it could be. I didn't do all that error checking because this is an object-oriented programming tutorial, not how to code an airport and flight tutorial, right? And now this is the delete flight method, again overloading, but with the flight ID. Finally, the toString method. Now this toString method is a little long again, but here's the string representation. Delta airport, start with the name of the airport, I just chose a random name. \n here means new line, so just imagine there's a new line there. \n list of the flights. I put this in capitalization because what it's basically going to do is use flights.toString to just make a list of the flights, you know. Then two \n because I want a gap, and then you list out the delayed flights. And that's what this toString method is doing. So we got an overview of Airport.java and Flight.java, and if you notice, this follows the exact same pattern. First you do the instance variables, and the constructors, and the accessors, and the modifiers, and then the toString. Now this isn't how you have to do it, it's just how I do it. It's a template to follow to make things simpler. And now this is TestFlight.java. This TestFlight.java is not the system, you know, that you would make when you're making an airport and flight thing, but what it's for is testing that our made objects work as they should. So here I've just started a program like you'd start any main program, public class TestFlight, because TestFlight's the name of the file. I added the main method, which is, this is how it always is, you can't change that. And I'm assuming you've done a little Java before this, so I'm not explaining every single thing. I'm making a random object. Basically how this works, it makes a random number, pseudo random number, which means it's based on an algorithm. ArrayList flights is TestFlight IDs. This is ArrayList, and this is times for testing, which is going to make local date times, you know, for the testing. Next, I'm just iterating, you know, over 10, making 10 times for testing, making a bunch of local datetime objects, and this is how you construct them. You can look at that later, but all you need to know is I'm making randomized local datetime objects. Here I'm again iterating over 10, but this time I'm making flights. That's what it's doing. TestFlight.IDs.add. I'm making new flights, so you can see I'm adding a time, adding another local datetime, a random one for the arrival, departing from LAX, string SEA string, airline name is Delta, and then this is the flight capacity for for a flight. That's just the flight capacity I'm randomly generating, 100 to 200. And now this is where the testing happens. So the first thing I'm doing is making a new airport with the TestFlight IDs for the flights. Total flight capacity 100, just a random number, and name is Delta Airline. Next, I'm just putting out the airline, making sure my println function works. Next, I just test all the methods of the Delta Airport object. And why I'm not testing the flight methods, because a lot of these Delta methods use the flight objects inside them, so I don't really need to do that. But I'm using that add flight method first, you know, just pass in a flight, passing in just this random new flight, irrelevant new flight object, and I'm printing it out again, make sure that flight got added. Then I'm delaying that random flight, I guess the one on index 2 in the get flights. So this is also testing get flights, making sure it works. But just the second index for get flights, delayed by 5 days 2 hours. Again, something random, but making sure it works. And then I'm delaying something using the flight ID. What about flight ID 2? making sure it can also find that flight using the flight ID. Again, I'm printing it out and making sure that progressively every single thing is working. Delete flight, I'm deleting get index 3, then I'm deleting by flight ID 6. What this is doing basically is getting that flight object. Finally, I'm printing it out, and that's my test program. It's very simple, it's very short, but it's making sure every single thing is working with my objects, so that when I go to actually create a useful program, I don't have any problems. And let me just run this for you real quick. I'm just running it, and terminal will come out, and it'll take some time to run because I'm doing a lot of things in the background as I'm recording this. You can see how that airport toString works. It's getting all the flights and then turns to the delayed flights. I can assure you this works. Maybe it doesn't, maybe I just missed something, but basically, yeah, that's how object-oriented programming works. You make some objects, you make a program for those objects to interact. You can make those objects interact within the objects themselves. You can look at all this code on the GitHub called Kid with the Camera, obviously. I'll link that down in the description below. And just remember to smash that subscribe button. I want to get up to maybe like 100 subscribers by the end of the month. Make sure to hit that like button so that my video gets recommended by the algorithm. Comment down below if you have a suggestion for me or find a mistake in my code. I'll definitely correct it as soon as possible. And thank you for watching. I hope you understood objects a little better and object-oriented programming a little better. But yeah, thanks a lot. This is Aryan from Kid with Camera. Thank you so much.